What's going on, guys? Welcome back to this video. Today we're doing Hack the Box, and of course we're carrying over with intro to printer exploitation track. I think I'm gonna need to remind you every time because I have new users coming and asking me what are you doing, what is the machine, what's part of. So it's part of intro to printer exploitation, and today's video will be on driver machine. So the name is pretty self-explanatory about the nature of this challenge. It's about drivers. But anyway, we're not gonna assume that we need to take hints from the name of the machines or from any other place, because in the real world scenario there are no such hints such as driver or the name of the machine, although you might stumble upon rare scenarios. But anyway, so if you click on that and we spawn the machine, we will get started. We need to retrieve the root and the user flag. Let me walk you through that. The first thing I did, guys, is the in-map scan, as we usually do. So the first thing, I scan for all the ports, an aggressive scan on this IP address, and as you can see we have several open ports. Among them we have port 80 and running Internet Information Service, a Windows a web server software running usually on Microsoft systems or Windows systems. So that's the first thing that we're dealing with, Windows server. These are the request headers, and as you can see we have an unauthorized request to this. So basic realm MFP firmware update center, please enter password for admin. So this means that if we browse to the main link or to the main page here, we're gonna be presented with a basic authentication challenge asking for username and password. We're gonna come to that. And we have port 135 445. It means we have SMB file shares running on this machine, and also we have 5000 or 5985. So these are the running services on the machine, the running ports. Alright, so the first thing I did is to browse to the main machine here, or the main page. As you can see, there is no challenge, there is no authentication challenge, because I was already authenticated myself. But let me show you guys how this works. If I try to authenticate again, I think I'm going to need to open that from an incognito mode or a private mode, because it's going to clear the cookies. Yeah, that's it. So if you try with username admin and password admin, you're going to be able to log in automatically. So that's the first weakness, using default credentials. And many scenarios I saw myself that people use default credentials on their printers. So they leave the web interface configured with default credentials, and then you can easily get access. So that's what we have, MFP firmware update center. MFP, most probably it's an HP printer model. It belongs to HP. So if we navigate through these menu tabs, the only one that is functional is the firmware update. Now in the firmware update, it offers you to update the firmware or send your version or send a firmware update to the manufacturer. It's like a collaboration. So what you're going to do, you're going to upload the firmware through the browse button, and then this version or this image of the firmware that you have just uploaded will get sent into the team to inspect it. But where? As you can see, select printer model and upload the respective firmware update to our file share. So we're going to assume that this version update that anyone can upload supposed to be uploaded to the SMB file share running on the machine. So here, after it is uploaded, the team will open the file share, navigate to the file share, and inspect the firmware update that we have just uploaded. So they might be opening it, or they might be they're just gonna inspect it. So the scenarios here are clear. We're gonna need a reverse shell, but reverse shell in this scenario is not gonna work because it is a file share, and most probably there will not be any execution for any shell we upload in this scenario. So we're going to use a classic common method to get a shell on this machine in this scenario. So basically here we have a file share, and it is a Windows machine. So basically what we need to do here, we need to let the file share configured on this machine to connect back to us. During the connection process, it's going to be challenged for the authentication details. Most probably we're going to aim for the NTLM version 2 or not NTLM. So let me tell you guys how it's going to work. So basically we're going to configure a file with the extension SCF. So as you can see here, we call this a Windows command shell file. So basically Windows command shell files are probably configured with SCF extension. This is the wrong extension. Let me show you how it looks. I'm gonna need to open a new tab here. So ls, so that's it, shell.scf. How this looks like, cat shell. As you can see here in this file, once I upload this file, the machine on the other end will browse this file and open it because it's a file share, and then it will do a request or initiate a request through the Windows Explorer to this path. So why we reference an icon file on my machine? Though this address points or references an icon file on my machine. When I upload this file or the Windows command shell file, when I upload this Windows command shell file to the file share mentioned here, the Windows Explorer on the target machine will try to open this file and initiate a request to the file share here through the icon file. If I use anything else, it's not going to work. So this is a common method to use icon files to exploit file shares and make the file shares initiate a request to an attacker controlled machine. Now this is not going to give you reverse shell obviously, but it's going to do something unique. So basically when it is requesting the shell.icon file that is virtual or non-existent, my server, okay, will ask for the identity of the target machine. In this case, it's going to ask for the authentication details from this machine, and the weakness here is that on this scenario, what's going to do, it's going to reply with the username and the hash, specifically the net NTLM version 2 authentication hash. If I have a listener opening on my machine, it's going to capture these details. So the steps are like this. First, I create this file with the extension .scf, and I reference an icon file, okay, on my machine. This icon file can be existent or non-existent, doesn't matter. I want the target machine to initiate a request. So I have the file ready. I go here and I upload the file using the browse button and I submit. Before I click on submit, I have to have a listener ready in my machine. That listener will need to listen on an active interface, and that listener needs to listen for any incoming requests for the share. So basically it's gonna have to include an SMB shared listener. So what I used here, it's a responder you all the time use. Responder includes an ability to listen for requests coming from file shares. So you don't need to use an SMB server. Just use a responder and use the active interface. The active interface is TUN0, which is the interface running the OpenVPN on HackTheBox network. Once I run this, my machine now is listening for all incoming requests, including the requests coming from the file share on the SMB protocol, which is a protocol the machine is using for running the file share. Now once I upload, going back to the last step, once I upload this and I click on submit, the machine will, using the Windows Explorer, the machine will open this file. It's now in the machine's file server. Once it opens the file, it's going to try to request this path, which is the path on my machine. This is the IP address of my machine. Now, it doesn't matter whether the shell exists or not. My machine will ask for the authentication details. And the weakness here is that the machine here will blindly respond with the authentication details of the current existing user under which the request is being made. So once I click on submit, quickly I will receive, as you can see, the authentication details through the SMB file share. That's a weakness in old versions of the server message block. Of course, there were updates that have been released against this vulnerability, but anyway, this vulnerability existed before. Many attackers use that to capture the NTLM version 2 authentication hash of any user. That's the weakness. So basically the weakness is when the file share was requested, or when the file icon file was requested, I asked for authentication details and the machine blindly responded. Okay, so now given that I have the authentication details of the username Tony, I'm gonna copy that to a separate file named hash. And we use John the Ripper with the word list raw queue. The format, don't forget to specify the format. It's net NTLM version 2 based on this. Okay, once you do that, you will be able to find the password of the username Tony. So that's the password for the username Tony, and I'm going to use Evil-Winrm because the port is open to log into Evil-Winrm and have the first shell. Of course, we're going to extract the user flag, not the point here. Now, other point I want to make here. There are two methods to elevate the privileges. The first one is through an exploit that targets the driver model here. Another one is the print nightmare. Now the print nightmare, there are a lot of videos, especially on my channel. I'm gonna put them in the video description, that teaches you how to use the print nightmare exploit. Technically, print nightmare exploit is a partial exploit. So basically it comes in the form of partial script that when it runs, it's gonna let you create a new admin user and log in with that admin user using Evil-Winrm. Simply, I'm gonna put that in the video description. Let me use the other method, exploiting the driver of this printer. So remember guys that you can upload any privileged escalation script on the machine. In that case, you should upload that script. What was the name of that script? WinPiece, yeah. WinPiece and WinPiece for Linux and WinPiece for Windows. Upload WinPiece if you don't want how to conduct manual escalation, manual privileged escalation. The manual method is, as you can see here, since we have PowerShell, if we try to cat the console history file, the console history file is a file that contains the history of the PowerShell commands. As you can see, it doesn't exist because I have to browse to the dedicated path that contains this file, which is under users Tony update roaming Microsoft Windows PowerShell PS Redline. Now, why this method? This is a common method, by the way. When you have a PowerShell session on any machine, it's a common method to peek or sneak into the contents of this file, which contains, because you are using PowerShell, right? This is a PowerShell shell, and it's pretty obvious that you want to see what are the previous commands that this user has executed. The same as when you get bash shell, you go into bash history file, right, and see what are the commands. Same here. So we see this command, add printer dash printer name. This is the printer name, and that's the driver name. All you have to do now is to Google the driver name, and you will come to this page. Local privileged escalation in many Rio printer drivers, RISO, for Windows CV 2019. So this is another exploit that you can use to solve this machine. Basically what happens here is that in this vulnerability, any user can replace the DLLs that are used by this printer's driver. So when this printer is added to Windows system, as you can see, any local user is able to overwrite program files or program library files with own code. So basically you can create, if you want to do that manually, you can create a malicious DLL using MSF-Venom and then replace any of the printer drivers DLLs with your own DLL, and the next time the printer is added or run, it's going to execute one of your own DLLs thus giving you shell. Luckily for us, we don't have to do this because there's already exploit to do that for us, and that exploit exists in Metasploit. So what we have to do here, we have to keep this running, but we have to upload another reverse shell that gives us a connection back to gives us a Metasploit shell, sorry. So basically what I did, we created, as you can see, a reverse shell that when executed it will give me Metasploit session. Okay, so it's just a regular exploit, a regular reverse shell executable. Create this. Now using the upload function on Evil-Winrm, you're gonna upload this, and when you upload this, before you run this, you're going to run MSF console and make sure that you have activated the multi-handler with your own IP address, the port of your own choice, and then you run this. Once this is running, oh, don't forget to set the payload. The payload must be the same payload that you have used when you first created the payload. It should be the same payload that you have used for the executable. Given that you have set this correctly, you're going to run, and after you run the handler, run the exploit, and you will receive the session. Okay, so why we did all of this? Basically because the exploit of this driver model exists in Metasploit, and it's much easier to do that using Metasploit to save your time. Now what we're going to do here, but to uncover this, we're gonna have to learn what it is. So we have two methods. The first one is to search in Metasploit using the name of this printer, right? So what we can do, I hope the session is still running. Okay, background, search, type, exploit, and we use the name. Is that right? Okay. As you can see, we have two exploits. The first one for FTP, and another one is exploit Windows local driver privilege escalation. So it can use this driver to perform privilege escalation. You can do that immediately. You can just search and then see what are the required parameters for this exploit. So basically, show options. Here it asks you for the L port. Make sure to choose an L port that is different from the L port you have used for this reverse shell. It's pretty obvious. So first here we used 4545 to capture this current Metasploit session. Now this will open a new session, right? So we're gonna use another port, the same IP address and the session name. Now when you run this, it's gonna work, but it's gonna make the session will die immediately. So what you have to do, you have just to migrate. Okay, now the original session was under Metasploit. Okay, so what you have to do, you have to migrate into another process. Most of the time, the most reliable process to migrate into is the Explorer, but we are unlucky because there are several other, more than one Explorer process running. As you can see, let's see, we have this one, and we have, let's see here, we have this one and we have this one. So we don't know which one, so we're going to use this option, migrate-in Explorer, and it's going to select the most reliable one automatically. Once we migrate the existing Metasploit session, now we can safely execute this. I think now you are confused what to do. Okay, let's go back. So we created now the Evil-Winrm, we run this here, and now we got the Metasploit session running. Here it is. Now the indirect method is to use the exploit suggester. So we use background, we background the session, and then we use the local exploit suggester to let Metasploit run all the available exploits on the current session. It's going to suggest you these exploits. Let me scroll all the way here. As you can see now, these are the exploits suggested. Now we picked up this one. This exact same one, you can find it just by searching with the driver name. You don't need to run a local exploit suggester, but it's good practice to get used to it. It's very useful, especially if you have landed a Metasploit shell and you want to see what are the available exploits that you can use against the machine to perform privilege escalation. So you can get used to that by using it a lot, but if you know how to use it, you can save yourself time and search with the driver name. Alright, so we now know what is the exploit we're gonna use. Unfortunately, when we attempt to use that exploit more than one time, let me show you what happens. More than one time, let me scroll down. As you can see, more than one time, I get the session died. It dies more than one time. So when the Metasploit session dies, it means I have to migrate into another process. So the most reliable one was the Explorer. If you have more than one Explorer process running, just use this option -n, as can automatically use the most reliable one. Once you have migrated, now it's time to use the exploit, right? So we run this, we set the correct parameters, including the session ID. You can get a list of the session IDs using sessions-i. The session ID is 17, so we set session 17 and we run. When this is running, as you can see, get UID, we are the net authority system, and we can grab the flag of the root. That's the first method. The other method is to use the print nightmare exploit. The print nightmare exploit is here in GitHub. You're going to git clone this. Okay, now you're gonna face a problem, because when you try to upload this on the target machine, it's gonna prevent you from executing the script by virtue of the execution policy restriction. So what you need to do here on this session, just run this command: set execution policy unrestricted, and specify the scope -user current user. Once this is set, you can now safely upload this, clone this onto your machine, and use the upload function, okay, to upload the script. Now this script can be executed. Okay, once you do that, you'll be able to use the command import module, and then here we specify the name of the script, which is here. Okay, once this is run, what we're going to do, we're going to invoke the nightmare module. So basically invoke, let's see, so here it's illustrated, by the way, import module and then invoke nightmare. As you can see, this is the command. We're going to actually create a new username, and then when the user is created, we can use that user to log in with Evil-Winrm as an administrator. So there you go, guys, 2 methods to solve this machine. I hope you enjoyed the video, and I will see you later.